Before we proceed further for circuit analysis, we have to remember some more definitions that is related to the circuits. So the first one is called the loop. Loop is basically a closed path formed by starting at a node, passing through a set of nodes and returning to the starting node without passing through any other nodes more than once. The second definition is called mesh. Mesh is a smallest closed path, or it can be considered as the smallest loop of the circuit that has no other branches inside it. The next definition is called the node. Node is a point in a circuit at which two or more elements meet together. For two nodes to be different, then their potential must be also different. The next definition is called the junction. Junction is also a node or a point where three or more elements or branches meet together. So it is basically considered as a collection of the conductors at the same potential. Remember one thing, all the junctions can be considered as a node, but all the nodes cannot be considered as a junction, because junction is where three or more branches are connected, node where two or more branches are connected. The next definition is the branch. Branch is a path that connecting two nodes and should have a circuit element between the nodes. The circuit elements may be resistor, inductor, capacitor, or energy sources, either voltage source or current source. It can be also considered as the number of branch in a circuit is equal to the number of elements that present in the circuit. Let's consider this circuit and we will explain all the definitions by using this circuit. The first one is called the loop. So loop is the closed path of a circuit. So if we consider this circuit, here we have total three number of loops. The first closed path is considered as A, B, E, F and A. So it is one loop. The second one is B, C, D, E and B. Again this is another loop. And if we consider the whole circuit, that is A, B, C, D, E, F and then A, then it is another loop. So in this way, in the given circuit we have total three number of loops. Loop 1, loop 2 and the whole is another loop, that is the third loop. If we consider the mesh, so in this case we have only two meshes. The first one is called A, B, E, F, A. This is mesh 1, and B, C, D, E, B, it is another mesh, because mesh is the smallest closed path which should not have any other element within it. So in this way you have total three number of loops and two number of meshes in the given circuit. Next, the number of junctions and the number of nodes. In this circuit we have total 6 number of nodes, that is A, B, C, D, E and F. Because node is the point where two or more elements are joined together. So at point A, voltage source and R1 is connected. At point B, R1, R3 and R4 connected. At point C, R4 and R6 connected. In this way, at point D, R5 and R6. At point E, R2, R3 and R5. And at point F, the voltage source and R2. So we have total 6 number of nodes in the given circuit. And the number of junctions. Junctions is a point where three or more branches are connected. So in this circuit we have only two junctions, that is point B and point E. Because at point B R1, R3, R4. Total 3 resistances are connected here. Similarly, at point E, R2, R3 and R5. Again 3 resistances are connected. So B and E are considered as the junction. So in this circuit we have total 6 number of nodes and 2 number of junctions. Then the branch. Branch is a part between two nodes which should have at least one circuit element. So AB is considered as a branch because between A and B, R1 is the resistance. Similarly, between B and C, R4 is the resistance. So again, B and C is the branch. In this way, we have 1, 2, 3, 4, 5, 6 and 7. Total 7 number of branches we have in this circuit. So you have total 7 number of branches. Now we have to know some more definitions that will be useful for our circuit analysis, and this is considered as a short circuit and open circuit. So the definition of the short circuit, or what does it mean? The short circuit means when the resistance between two terminals becomes 0, then this condition is considered as a short circuit. And similarly, when the resistance between two terminals becomes infinity, then it will be considered as the open circuit condition. Let's have some example. Suppose in this given circuit, I have drawn a simple circuit with a voltage source V. R1 is a resistance and RL is a load resistance. A and B is a load terminal. According to the condition, we have to short circuit the load terminal, that is terminal A and B. Then what we will do? We will simply remove the load resistance from the circuit and we will join the terminals A and B by using wires, because wires have 0 resistance. So in this case, it will become a short circuit path, and the current that will flow through this short circuit path is considered as a short circuit current. Remember one thing, in the short circuit path, the resistance will always be equal to 0. Now for the example of the open circuit, we have another circuit, voltage source, R1 is a resistance, RL is a load resistance, and we have to make the load terminal open. So what we will do? We will simply remove the load resistance from the terminals between A and B. So if we open this terminal, it will become a open circuit condition. And remember one thing, for open circuit condition, the resistance between A and B is considered as infinity. It is considered as a infinity resistance. And as the resistance is infinity, then in case of open circuit, no current will flow in between A and B terminals.